the approval from parents to have them come to the library and do a couple of rehearsals. So considering the safety um, risk attached and the time and the stress it would be on the parents who have to bring their children to the library, we had to make it a adult program. And mainly, we started out with this idea. Um, we started out with this idea from our the head of the library, Miss Susan Pakalidi. She sends her regards as well. She was the one that brought the idea of this Guinness World Record, hoping that we could do something to make people aware of our collection, of the library, because this is part of the goals of the reason Qatar has these libraries. And we have a couple of libraries, and we really want people to come and use this books that we have to come and see these objects and know more about Islamic art. And we were looking for how to really do this. And she came up with the idea to do maybe break a record or set a record with Guinness. And in connection with library goal, which is reading, we started out looking for which which material is what we could do. So at first, we really wanted to do like a recording, maybe like a marathon recording, like 2 hours, I mean, 2 days, or the longest recording in history, reading, or something that we could do. But then we thought about the file, compressing the file, and all of that. I'm very sure that a lot of us here know about this, as I've heard that a lot of people work on text to speech. So I know you know about files, recording the audio, what could go wrong, and all of that. So uh, we started looking for other options when we considered that could be difficult. So we eventually came up with this, and we said we were going to uh, do something about reading in most languages because no one had ever attempted it. We thought it was going to be simple because it just seemed like just pick up a book and just read, just read your part. However, we never knew that language could be so complicated. It turned out really complicating uh, because according to the requirements we were given by Guinness World Record, we were told we had to look for at least we had to get at least 50 languages, and it has to be within the specific language code, the ISO 6392. We're not very familiar with that, but maybe people in this all could know more about that. But we're just given this document, and we're told that we should work within just within that range. So there were some languages that were not there, which meant that they were not considered official. So, and we had to use these official languages, and we had to get one specific book that would be translated into all of or would have been translated into all of these languages. And then we should have a reader and for each language, and each reader should read at least a sentence from the book. We have to cover the whole book. So it's like 50 languages. We have to divide the book within the 50 readers without missing any part, and not more than one language overlap. I mean, one sentence overlap. So let's say a person reads in Irish now, the next person wants to read in Chinese. The overlap between them because of translation should not be more than a sentence. I also understand that a lot of people know about languages, so you know how it is with translation, that it's possible that I say this in English and you want to say it in your language, and you have to take part of my sentence to make your own sentence before it could make sense. So that was why we were given that. And then it had to be just 10 seconds gap between each language to transition. So it's like you're done reading Irish, the next person to read Chinese should start before 10 seconds is over. So we faced a lot of challenges, just like I mentioned, beyond what we actually thought uh, could be the what to look forward to. So first was the translation. So we had to look for official translated books. Um, Guinness was very particular about that. So it wasn't just like some people would sit somewhere and just say, I can speak Spanish. So because of that, I'll just translate the sentence and just read it. No, we had to get the complete book, even if the person will be reading just the sentence. So that meant we had to get 50 books in those languages. And this was where the problem came from. A lot of the books we got abridged versions or dialects, like Arabic. At first, we got this Iraqi version, and we were told, no, that's not really Arabic. That's just like a dialect. And it was like the first time we were hearing about that. Like, so there's the original Arabic, and then we could have this other Arabic as well published. So for us, it wasn't just about the publication, it was more about getting the original translation because Guinness was very particular and rigid about it. We were not allowed to use any abridged version. And this could cost a lot because, I mean, we paid for the Guinness World Record and it was quite expensive. So the last thing we wanted to do was mess it up with getting a wrong translation. So another problem we had was that some well-represented languages in Qatar did not have the book translated. So as it works in Qatar, trying to get people to participate in this project, as much as we could do online publicity, it was easier to do a mouth-to-mouth advert. It was easier to talk to your friend that actually speaks this specific language to say, oh, please can you do this language for us? And then we got some people, and the issue was to get their book for them now to read it. And my language was one. I had a lot of people around me who I could easily contact and say, we need people to help us read, but the book had never been translated to my language, which of course I really wanted my language to be a part of the project. So I had to officially translate the book to my language. And the book we used was The Little Prince. I'm not sure if a lot of people or are familiar with the story. The Little Prince was originally written in French. So it has been translated into over 500 languages. But then my language was not a part. So I had to take that upon myself and translate it to my language, which was a bit tedious as well. Because at first I contacted a linguist to help out in translating. And when the person sent it back to me, it turned out the person actually used a software to translate the the whole text. So it didn't read well when the person sent it back to me. So I was like, okay, this is not really what I asked. And she was like, it's not easy to just sit down and transcribe from this particular language first to English and then back to your language. So I had to use the software. And then I was like, that means that, there's also that issue with using technology. And I had to come in to correct the script myself to make it readable such that someone who speaks my language could actually pick up the book and relate with it. Okay, so we also had the problem of the spoken versus the written aspect of the language. So like an example is Chinese. We had problem with Cantonese and Mandarin. We were really confused because some people were telling us, no, the writing is the same, but the speaking is different. And that really gave us a lot of tension because we didn't want to make any mistake with the project at all. And then the readers and the judges, we had to get judges. We needed 50 languages that we couldn't speak, Guinness couldn't speak. So we definitely needed people to help us to um, confirm that if somebody is reading in Spanish, it is truly Spanish. Because I don't speak Spanish, my boss doesn't, so someone had to be there. That was why we had to have the judges. Considering Qatar is very small, it was really difficult to get readers and judges who could speak this language. And then Guinness made it even more difficult for us by saying the judges had to be official translators, which is a bit difficult if you agree with me, because they were like, okay, contact the embassies and probably get official translators from there. Most countries don't even have embassies here. So we had to contact some instructors from HBKU who work in the translation department. So they were the ones who were able to supply us people who could read at least like 5 languages or more. So in making the script, this was one part that was really difficult for us. We had to divide the book between the 50 people, just like I mentioned. And at this point, we had to use Google Translate because that was the easiest way we could go about it. And it really got complicated because we were, as much as we were trying to hold on to the rule of Guinness that we shouldn't be repeating more than a sentence in between. The translation from Google was not as accurate as we would have wanted. So it was really difficult for us, and it meant a lot because we could lose on just that minute detail. So we had to get people to come physically to tell us, okay, if you just read in your language, can you tell us in English where your language just stopped so that we could divide this really well and would be sure that, because we later noticed that a lot of people were missing up to like a paragraph in between because Google Translate actually played with our intelligence a little bit. And well, I guess this would also bring me to say that if there's any way the work that any one of you is doing could help the reading or what you think you can do in the museum to make, because we wish we had a more accurate technology that could help us at that time, because the time was really short and we really needed the accuracy. However, we had to use humans because there was really no way out. I mean, Google is fantastic, is amazing, but it was not as accurate as we really wanted. And so we would appreciate if, even in operating the catalog in the library, because presently we only have the catalog in Arabic and English. So if it's possible that we could probably get it in other languages, because people are come from all over the world, just like you're here, and you want to visit the museum and you really want to feel connected to the museum as well, especially those whose religion is Islam. When they come to the museum, they really want to find something to relate with. However, it's difficult for the museum sometimes to present as much to them because we can only speak either English or Arabic to them, and the catalog is only available in English or Arabic as well. So, I mean, we are welcome to suggestion on how this could be improved if anyone has any way to help about that. So I'll just say that what we learned about the whole project, working with language, and the what we were able to discover. So first we discovered the beauty of language despite the diversity. So just like I mentioned, we were unable to understand people. We organized Zoom meetings at first just to get people to read in their languages and let us listen to you, and we'll be sure you're fluent in your language and you could read it. And it was really beautiful just listening to Turkish, Kurdish, Tamil, Hindi. These languages were from different parts of the world, but coming together in audio. It was really amazing. We're literally getting these goosebumps sometimes, like, wow, amazing. And some of them just keep laughing at us, like, do you understand what we just said? You're not even sure if we just said gibberish. And we're like, I mean, the tone itself was really beautiful. And that was one of the things we discovered. This picture is from the day of the event. So we discovered again that language connects people. Some other people could understand the languages of other people. So like Kurdish and Turkish people, I think they have the same basis. It's just at some point that they have these differences. So it was more like we just arranged the languages the way we could, because at first we thought it would be about the FIFA World Cup, but it turns out that some countries did not qualify. So we had to just go with language, not countries. So a Turkish person sitting next to a Kurdish person is like, oh, I understand what you're saying. That really sounds like my language. And a Persian people with an Arabic person saying, I can see your alphabet, though I can't understand it, your sentence, but your alphabet just looks exactly like mine. And they became friends from there and just connected. We also discovered the language connects other aspects of culture, just such as costumes. So we didn't expect this to be part of the project. It wasn't really part of the picture, but it came out uh, beautiful. And that was because of language in the first instance. Um, so our discovery, we discovered that there's a connection between language and self-esteem. So this is something we never really thought about language. A lot of people came to us and they said, please, I just want to participate in this. I just want to make my kids proud. I want my kids to speak my language. I want them to like listening to my language. Maybe if they see it on a platform like this, they would be more interested in the language. They would want to grow more into the culture. And we were like, we set out to do this on a different note, but this is another discovery that we didn't know really existed, or a burden, I would say, in the heart of parents in an expat country like this, having to grow their children in the culture. And language as well brought people of different social status together. So it was all about language. We didn't care if the person had PhD or the person had masters, or the person was, with respect to every occupation, people came from different occupation, and people were just particular about the language, about reading in their language, about other people listening to their language and making it as interesting as possible for people to hear. So also we talk about language connects history. So a lot of people in rehearsals just meet and they just get to start talking about the fact that let's say this man in this picture is a Kazakhstan. He's from Kazakhstan. He read the Kazakhstan language, and a lot of other people, Tajikistan, uh, they all came together and started telling the history of how they relate and all of that. And from there, they connected, which is something we really did not think that would be part of language, as it were. We just wanted to set the record. And language is an art that people could master. So these three people here, the first lady, the Russian, she read the Russian language, but she is an Indian lady, which meant that we were not particular about the fact that you have to be from that country or that specific culture to read that language. All we needed was you could read it, you were fluent, you understood it, and you could read it. This man in the middle is a Qatari. and he read the Japanese. He read the Japanese language, and it was quite fluent. And the Japanese embassy was really proud of him. The last person is Turkish, but he read the German language fluently. You would never have thought that he's not actually from Germany. And the influence on the facilitators now, those of us who organized the program, um, it was really a way to know people, a bigger community in Qatar, and just like it might be difficult to pronounce my name. The same way it was difficult to pronounce a lot of people's names. So we would rather recognize people by their languages and just say, oh, the Russian lady, oh, the Kurdish lady, because it was easier for us to recognize people with languages than trying to call their names out, which is quite interesting because we made friends and we saved people's numbers with Tife Yoruba, um, Saha Turkish, or something. These all came from the root of language. So for this project, we created this Instagram page, Let the World Read. That was the title we gave to it. We couldn't give it the Guinness World Record because of logo license issue. So if anyone really wants to follow up the work and get more details about what was done. We really want the what we did on this to continue, which is why we were excited about this conference to talk about what we did and how it could be improved, what other things we could use it for, and how people could still benefit from it, because it was not just about getting the certificate. It's more about getting people into reading, getting people into these languages. So we're welcome to suggestions. Maybe after going through the page, if you have any suggestions for us on what we could do to improve on it and keep building on the project. And this is the MIA website. The library is always open from 9 to 7 p.m. And you don't have to book ahead before coming. We have collections in Arabic, English, and every other languages. We're able to get the material about Islamic art. So you may find it interesting to also come around to check the collection and um, find something interesting for yourself. So for this, I am done with the presentation. If anyone has questions or anything about the project, I'd be happy to.
Okay, so all the questions, I think many of the topics you raised, um, many of the topics. Okay, thank you for your great talk and insights. I think there will be many questions because many of the topics you raised, the audience has to suffer with likewise. So who wants to go first? Yep.
So I would mention Czech first, because it was at some point we were going to give up on the language completely, because I think they have a very small number of people here in Qatar speaking it, and we initially set out to use like Albanian, Danish. We couldn't find anyone, so we had to drop most of those languages.
I'm just curious, were there any indigenous languages, whether from here or from other parts of the world?
Oh, yes. So the way we arranged the languages, we started with French because the book was originally written in French, and then Arabic is like the language of the Middle East, and since we're doing it here in Qatar, it was the next language, and I guess Arabic was the only indigenous language we got from here, apart from Persian, which is a little bit connected because it's spoken in Afghanistan and
I meant something like minority languages, even within a nation like Tamazight in Morocco. Although it's official, it's I don't think it's quite as widely spoken as French or Arabic.
I'm not sure if I get your question well,
But that's okay.
but you mean that maybe some, let's say a language found in Morocco that is not maybe widely spoken, but you want to know, okay, so just like I mentioned, we had to stick to this specific language code. So some of the languages weren't found in the list we were given, so we couldn't include them.
Okay. Thank you.
Any other questions? So maybe one more from my side. I assume you recorded the session.
Yes.
Would the audio and video be available? Because maybe for the audience, as building multilingual systems or improving them, maybe they could use the audio and try to subtitle it or use it as a benchmark. Maybe that's something where we can work on and improve on.
Hmm.
Would it be possible to get hold of the data and use it in the science community?
So the recording was actually done by Qatar TV. Although I think the museum also had representative recording, but I can't say how the data, but I think that is something I could communicate with you
Okay.
personally later too.
And then the audience likely would need to take it up as a challenge, and then maybe that's something as a topic for one of the next workshops then.
Yes, honestly, I would be happy if anyone could do anything on it.
Okay, any further questions? So thank you very much for your wonderful talk. Let's give you an applause again.
Thank you.
Thanks. And with that, I hand on to Peter, who will have a couple of minutes time to switch then the setup, I guess. So stay tuned.
Yeah, so the next item on our program is a keynote from Farina Risa Harriet Watt, but as you'll have noticed, we're running a little bit ahead of schedule now, so we've got 15 minutes, I would say. When I last checked, desserts were still available, so I would head out there, grab a coffee, grab some dessert, and come back in about 10, 15 minutes for Farina's talk. Thank you. It's on Zoom now, yeah. So you just have to shut that, yeah. Yeah. Yeah, all good. Yeah, I'm going to go and do my own suggestion. It's on, can't I? Yeah. Yeah, it should be fine. Yeah, it's okay. I think it's yeah. Yeah, that's close. So that's all good. So that's good, thanks. Yeah. Yeah. Very much. Well,
Great. Sì, just one minute. Just when you speak, when she speaks, otherwise, it's a good time. I need to move like that.
That's not showing. You had it perfect a minute ago.
Yeah, because we changed it because I'm not second English. Okay.
Oh, right. But on a minute. So it's on. It'll be on the whiteboard and stuff. I think you might want to very slightly change the size of how it's maybe smaller. Maybe
Well, hello everyone, and welcome to our second keynote of today's conference day. It's my very, very great pleasure to welcome remotely Farina Risa from Heriot-Watt University in Edinburgh, where she's Professor of Artificial Intelligence and is also a co-founder of AI company, Alana AI, who's specialized in conversational intelligence. So Verena has a long history in Edinburgh. She arrived in Edinburgh before I did, actually, in 2003, where she studied for an MSc. And although she went back to Germany for her PhD at Saarland University, she did visit Edinburgh as a visiting PhD student in 2007, and then came back to Edinburgh for postdoctoral research in 2008. In 2011, she was poached by Edinburgh University's rival in the city, Heriot-Watt University, where she joined the faculty and rose up through the ranks to become a professor. So Verena has done lots of very interesting work that could be said to specialize in natural language generation for conversational AI. She's had numerous research grants, I think totaling probably more than $6 million in her career. And I'll just find some highlights. Perhaps a couple of highlights are a Leverhulme Trust research fellowship, and also a grant that I believe is still active from the UK funding councils on looking at gender bias in conversational AI. And so we're very, very grateful to her for joining us at SLT at the last minute. I heard today she's battling a schools strike in Edinburgh today, so we're doubly grateful to her for taking the time to join us for what I think will be a fascinating presentation. So thank you very, very much, Verena.
Talk on the mic. Take on the mic. Use the mic. You can tell her you can start.
Okay. So you can start now. I think you were coming up a bit quiet, but we'll have another go. Wait a second.
Just a second.
Yeah, thumbs up to me.
Yeah, a little bit.
Okay, ready, steady, go. Okay, fantastic. Well, thank you so much for inviting me. So my name is Verena Risa. I missed the introduction. We had a couple of technical hiccups. First of all, I want to apologize that you have to sit through yet another online presentation. I agreed to give this talk quite last minute and I was unable to rearrange my schedule. But in order to make up for it, I decided to give you a slightly unconventional talk, which I hope you will find entertaining. I will attempt to provide you with a very short history of data-driven dialogue systems, which I have arranged in 5 acts. And I will conclude with a future outlook of what I think lies ahead in this field. So why I talk about history? So dialogue research is in fact one of the fastest growing communities within ACL. So when I started, it was considered a bit of an exotic outlier with not very many submissions. And now, as you can see from this graphic, it has actually overtaken machine translation in terms of the number of submissions received at ACL. So this was 2020. And as I'm sure you're all aware of, dialogue is now prime interest for the public. So since the release of OpenAI's ChatGPT, almost everybody on Twitter and social media is talking about it. I'm sure maybe even your families have now heard about it. But not many people are actually aware of the complexities. And that's what I'm hoping to convey in this talk. You might be wondering whether I will attempt to cover all previous research in this area. Well, obviously not. I will give you a very highly subjective view through the lens of 5 major research initiatives I was involved in. I was lucky to start this journey exactly 20 years ago when data-driven systems were at their infancy, and I have spent the last 20 years exactly doing that. So before working on dialogue systems, I actually got a degree in literature studies. So I have decided to structure this talk according to the dramatic structure proposed by a German playwright called Gustav Freytag in 1900. And according to Freytag, a drama is divided into 5 acts. So it starts with an introduction of one of the main actors and the concepts. Then there is a rise in action before it reaches a so-called climax, which is also a turning point. And after this turning point, there's a return or fall. That is some negative event which foreshadows the final catastrophe. And for the final catastrophe, according to Freytag, the hero should actually be killed for an increase in dramatic effect. So what does this mean for data-driven dialogue systems? So in the first act, I will talk about rule-based systems and that they are indeed data-driven to some extent. That is, they're often informed by data collections. In the second act, I will describe the rise of data-driven systems with the introduction of reinforcement learning. And I know that my good friend Roberto Piericini is in the audience. He was one of the main pioneers to introduce this paradigm into the field of dialogue systems. In the third act, neural models then enter the scene. And then the story makes a dramatic turn with the famous stochastic parrot paper by Emily Bender and colleagues, which leaves me to discuss the last act. Can we turn this into a happy ending? And for each of these acts, I will discuss the data people typically use, some of the prominent models, interesting advances in evaluation techniques, and then finally the overall system design. But before I launch into the first act, let me just briefly set the scene. So 20 years ago, Professor Steve Young, one of the pioneers of data-driven dialogue systems, describes a system as follows. So first you actually start with a speech signal, and then which gets transcribed by the automatic speech recognizer into a hypothesis, which also contains disfluencies, which then gets parsed by the natural language understanding module. Alternatively, you can obviously have typed text input. And then the NLU outputs a semantic frame, usually in the form of what we call a dialogue act. So you have some sort of intent and then entities, which then gets passed on to the dialogue manager, which interacts with some sort of back end, and then comes up with a decision of what to say next, again on this abstract representation of dialogue act, which then gets passed on to the natural language generation module, which then translates it into a textual response. For spoken interaction, you have a text-to-speech synthesis. So 20 years later, the architecture actually looks drastically different, which might be more familiar to some of you. At least this architecture is used for research. Industry systems usually still use the modular architecture. So we now module dialogue as an encoder-decoder model, where the encoder also often encodes some previous dialogue turns, also known as the context. And also note that it's actually assumed that now the interaction is typed rather than spoken. The main advantage of this architecture is that we got rid of any interim symbolic representation, such as dialogue acts. And not relying on annotated or so-called graded data now opens the way for self-supervised learning on very large data sets. And learning on these data sets now lets us almost perfectly mimic or parrot, as some people might say, human behavior, warts and all. So now that I set the scene, let me introduce you to Act 1. So I built my first dialogue system exactly 20 years ago. And that was a talking washing machine called Hermione. And Hermione was exhibited at a big German trade show called CeBIT. And to everybody's annoyance, stole the show of pretty much any other exhibit. The reason was that I actually programmed Hermione to tell jokes, similar to Alexa's Easter eggs, and people absolutely loved it. So how did we build Hermione? Well, first of all, we collected data from potential users. eliciting ideas of what they would expect when talking to machines. And at that point, not many people have actually ever spoken to a device, which is very different from now. And this type of co-design is also called a participatory design. And there's a very good article, recent article by Virane et al. Then in a slightly more advanced version of this type of systems, people would actually get inspiration by analyzing human-human interaction. For example, I analyzed how humans generate clarification requests and then implemented that into rules. And the models we used back then were, as I said, rule-based, either using a simple markup language called voice XML at the time, or implementing a theory of conversational grounding using method we call it information state update approach. So the more interesting part is the evaluation, which typically involves both quantitative as well as qualitative measures. For example, we would conduct structured interviews. So overall, the approach can be summarized as a mixture of rule engineering, but also human-centered design. The latter has recently become more on vogue again. So for the second act, I will briefly talk about reinforcement learning. So this is a topic I could go on and on about, as I did my PhD on RL for dialogue systems. So reinforcement learning is based on the idea that you have an agent that can take actions in an environment and then observes the resulting changes in the environment. And this is implemented at state in terms of states and rewards. And then it uses these observations to recursively update a value function, which assigns a value to every state and every action. And this is based on the estimated reward and the future rewards. And also a transition function, which represents the likelihoods of the environment. So this is implemented usually as a Markov decision process or a partially observable Markov decision process, also called a POMDP, and the latter explicitly models uncertainty, for example, the uncertainty we get from the speech signal. Now, for dialogue systems, we initially used symbolic representations for the state actions and rewards. For example, for the states, we represented them in terms of the information state update paradigm, which I already mentioned. You can see an example here, and the actions were on the dialogue act symbolic level. The rewards were typically based on our intuition. So for example, we would assign a negative reward for dialogue length or a positive reward for task success. To estimate the transition probabilities, I mentioned you had to have in-domain data. And one way to get this data was to actually build a system, or ideally more than one system. And two examples here is the communicator corpus or the Let's Go system from CMU. And the really exciting part here is that we actually had real users calling up these systems and interacting with them, which is, more advanced than the dataset collections we're currently using. But it's also very expensive, and the strategies you can explore are limited. So an alternative and also much cheaper method to get in-domain data was to do a Wizard of Oz experiment. So in a Wizard of Oz experiment, you have a human pretending to be the system, and the user is left in the belief that they're interacting with a real system, and then also evaluate the system in the end. You might have heard of the multi-WOS dataset, which is an extension to two previous dataset collections for a tourist information system called CAM Info, Cambridge Information, and then Town Info, which mainly included Edinburgh restaurants. So here the interesting part was that we're actually not just interested in what the user does, but we are also interested in strategies human wizards choose to explore. So the evaluation was also in some way more advanced than we typically do evaluations today, or at least it pre-shadows some of today's research themes. So human evaluation was usually standard, and automatic metrics were usually learned to estimate human evaluation. So for example, a very popular model, which you can see on the slide, was called Paradise, which uses a regression model to estimate user satisfaction from observable parameters such as dialogue length. This pre-shadows many of the reference-less metrics people explore today. In addition, people looked into standardizing human evaluation, and again, there are some current efforts in this direction. So overall, you might say that system design was a mixture between feature engineering and wrangling small data sets. So for data sets, we actually, as I mentioned, we had these Wizard of Oz in-domain data sets, which typically only included a couple of hundred dialogues. However, reinforcement learning is very data hungry. So the way we digged ourselves out of this hole was by just simulating everything we needed. So we simulated our users, we simulated our reward function, and we also simulated a speech recognition error model. And the idea was then once that your system is good enough in simulation, you can continue to learn online with real users. So despite being a theoretically very appealing idea, there are various drawbacks to reinforcement learning for dialogue. So for example, there is likely to be a mismatch between the simulation and reality, which is also known as the sim-to-real problem in robotics. Furthermore, the system designer has to manually specify the reward function and the state space and the action space. And believe me, this can be a real nightmare. I spent several months with my PhD to try to figure out the correct state space representation. And then finally, the overall system architecture was modularized, as I mentioned, and all of the models were optimized separately. So in the end, when you stuck them back together, there's likely to be a mismatch. So for example, this can lead to a severe mismatch between the dialogue manager and the NLG module, which basically led to systems which have no idea what they just said. And this is a problem which, by the way, is still persistent today. So now to the act where most people, I think, will feel more familiar with. So now neural systems entered the scene in about 2015. And at this point, we've got familiar encoder-decoder architecture, for example, here based on LSTMs. So these models were still based on or trained on highly curated dialogue corpora. So for example, daily dialogue or the Ubuntu dialogue corpus are one example. And in terms of models, as I mentioned, we've got generative encoder-decoder models, but we also have discriminative re-ranking models for closed domain systems. The evaluation, interestingly enough, changed quite a bit. So now these systems are not just generating dialogue acts, but they're actually generating words. And people started to use well-known metrics to measure similarity, a word-based similarity, such as bleu, with a human reference. So you might say that building such a system is now much more model-focused, and people experiment with different neural architectures. So let me just give you one example of how we research in this area, how we use these domain-specific end-to-end systems. So here we are still not completely end-to-end. We are just looking into data-to-text for task-based dialogue systems where the task is NLG. So you translate the meaning representations, in this case, a dialogue act from the dialogue manager into a natural language target. And the way we did that in pre-neural ways was we first had to actually learn the alignment between the input token and the output tokens. And this was a very difficult task. So with the advent of neural architectures, we were now able to learn this mapping in latent space. This saved us a lot of manual annotation effort. So this was really exciting when that happened. A lot of people immediately switched to this new architecture, and myself and two of my postdocs were wondering how good these systems really are in generating natural sounding dialogue output. And in order to get this type of data, we collected data using crowdsourcing, and we showed the crowdsources pictures representation instead of text representation in terms of, in order to not prime the crowd workers. Indeed, we got much more natural sounding, more varied outputs. So they were much longer, using a much more varied vocabulary, and also including discourse markers. And we used this data set for a shared task we call the end-to-end NLG shared task, which still is used as an NLG benchmark. So I'm not going into all the details. I just want to highlight some of our findings. And in particular, we found that end-to-end neural models, which are the ones highlighted here in purple, were not consistent with the input. So people now also refer to this as being unfaithful to the input representation. So, for example, we found that a lot of these systems produce hallucinations. So they introduce values which were actually not mentioned in the input. They substitute values, and also often omit to mention something which is specified in the input. And this is obviously a problem if you use the system with real users, and it will affect user trust, because the system is effectively lying to you. So very briefly, what can we do about it? So here, one idea is to reintroduce some of the ideas from pre-neural systems. So in pre-neural systems, we had a step called sentence planning, where we looked at input ordering and input aggregation. And in a paper which we published at ACL 2021, we were able to show that reintroducing sentence planning and modeling it as an HMM actually helps to increase the correctness of these models. We also reintroduced another symbolic method using called semantic role labeling to create these initial alignments, and we were able to show that this actually increases robustness to nodes. So instead of going completely end-to-end, but this is still completely end-to-end, but instead of going completely neural, we can gain control by introducing or reintroducing some symbolic methods. So now to the fourth act, which I believe we are in now, using massively pre-trained models. Some of the early examples in dialogue research is Dialogue GPT, BlenderBot, and Mina. People very quickly converged to a transformer architecture, as anywhere else in NLP, and the evaluation was still all about mimicking humans. Now even asking raters or Amazon Mechanical Turk workers to indicate how human they find the system. Something which I, in general, tend to disagree with. So the real challenge I think we face with these systems is safety. And let me tell you why I think safety is the real challenge. So some of you might have heard of the Amazon Alexa Prize Challenge. So this is a shared task introduced by Amazon, where university teams can compete to build open domain systems. And the really interesting part is that these open domain systems are then tested with real Amazon customers. So very interesting and rich data you usually don't get your hands on when you work at the university. So this motivated us to enter this challenge twice in 2017 and 18, and we won third prize twice in a row. To start with, we approached this challenge, I would say, quite naively. So we read all the research paper and we implemented an end-to-end encoder-decoder model, which we trained on very big data sets. So anything we could get our hands on. And the results were maybe unsurprising for today's research, but first of all, the output was very boring, and people addressed this research problem in terms of re-ranking and different decoding mechanisms to make the system more varied, more varied. But we also found that if the system wasn't boring, it often output something which was very much inappropriate. So, for example, our system would say something like, "You will die," which is a short, frequent utterance we think our system learned from the movies. At Christmas time, our system read out a headline saying Santa is dead, which we know about because a very upset parent actually contacted Amazon. And we are not the only one experienced this type of problem. About at the same time, there was the Microsoft Tay incident, where Microsoft released a bot to learn from online data, and it very quickly became racist and sexist. So now, a paper published at ACL last year already, yes, 2022, we call this we call this the Tay effect. So this means that the system itself generates inappropriate language. We also found that these systems very often agree with whatever the user says, which is a problem, obviously, if the user says something hateful. And we call this the ELISA effect. And then finally, we found that these systems are very ready to give advice in safety critical situations, such as mental health, and in this case, also financial advice. And the last example here is very interesting. So the user says, shall I sell my stocks and shares? And the system says, sell, sell, sell. So from a dialogue perspective, this is perfectly mimicking human behavior. But in this case, it's unsafe behavior, and this unsafe behavior is actually not picked up by current evaluation practices. So you might say, is this now, the turn towards the catastrophe, or can we still turn this around towards the happy ending? And this is what I want to briefly discuss in the rest of this talk. So where do we go from here? So some people might blame the data. I'm sure you all heard of the stochastic parrot paper, which makes the point that learning from big data sets basically mimics and reinforces stereotypes and behaviors, which is based in the data. Other people might also say it's the model. For example, there is a paper at ACL in 2020 called Climbing Towards NLU, which basically makes the point that there is a distinction between form and meaning, also called the octopus test, similar to the Chinese argument, meaning that these models actually really don't have an understanding of natural language. And there's also might be a problem with the evaluation, as already mentioned, mimicking or trying to mimic human behavior might not be the best way to evaluate these models, because often we actually have human behavior we don't want to closely mimic. And then finally, myself and my colleagues made the point that sometimes it's also the design of these models, and I will get back to this point later. So first of all, we explored the hypothesis, can we actually fix the data? So we got a sort of semi-automatically cleaned data set from an industry collaborator of ours, and where we trained our model on. And in fact, what we found was that this can actually address the Tay effect. So if it hasn't seen certain words, certain slurs, it can't generate those. But it doesn't address the two other effects, which we call the ELISA and the counselor effect. So for example, it still agrees with whatever the user says, and it still gives unsafe advice. So if you can't fix the data, how about fixing the model? So this is another attempt here, where we are actually trying to fix the interaction model using knowledge graphs. And the idea is that instead of just repeating or parroting or responding to anything the user says, we give the model the ability to actually take initiative. So this is called a mixed initiative model in dialogue research. And we achieve this by grounding the interaction in knowledge graphs. So here then the system can basically introduce new and relevant topics which are still coherent with the conversation. Another trend which I briefly want to mention is reinforcement learning revival, which I'm obviously very happy about, but now it's done via learning from human feedback. So it's also called RLHF, so reinforcement learning from human feedback. So now instead of having a handcrafted reward function, we now have a reward predictor from actually human ratings. So now the focus very much goes on to how do we collect this human feedback. And from previous research, we know that collecting human feedback is quite troublesome. So for example, we found that human ratings are not always reliable and vary significantly across different experimental settings. It's also often not clear what concepts humans actually evaluate. And there's lots of disagreement in research what concepts they should evaluate. And also we find that raters, human raters, very often disagree. So there's a wide variance of what people actually find good or bad. And so one question is, how can we model these conflicting values or these conflicting perspectives people have? So these are all open research questions in the space, both for human evaluation, but also if we want to use human evaluation as part of a learning from human feedback framework. Unfortunately, there's even more trouble with humans. So as I mentioned, we were lucky to be part of the Amazon Alexa Challenge, and we had this data set. We also had a couple of more data sets which we're able to analyze. And what we found is that our bots and also other bots get a very high level of abuse. So we found about 5% abuse. Other people report up to 30% of customer interaction containing abuse by customers or users. And one of the troublesome things here is that a lot of the abuse is actually gender-based. So that's based on a manual annotation we did on this data. And this may actually be have something to do with the current design of these systems. So a lot of the commercial systems are designed to impersonate a young, quite attractive woman, typically just age 18. And this is also often referred to as the honeypot principle. So people are more likely to interact with your bot. However, this can also backfire, and this was also pointed out by a UNESCO report, which was very influential a couple of years ago. They also pointed out that, so they called it the feminization of voice assistants, and they also pointed out that it's not only the gendering, but also the general problem of anthropomorphizing voice-based interaction. So there's now a general question, can we actually design systems which are less anthropomorphic? In a recent paper, we looked into gender clues these systems give, but also general human traits and abilities. So for example, these systems claiming to have emotions or do human activities such as eating, sleeping, drinking, etc. And here the data-driven approach comes back in, because obviously we've trained these systems on human data and humans do all these activities. So there is a question of whether we can actually train systems who don't claim to have human traits. So coming back to our dramatic structure and summing up the talk so far. So in the beginning, I argued that there are rules informed by data, and I have used a system called Hermione as an example. Then I gave you a very quick overview of reinforcement learning-based dialogue systems and the challenges of learning or bootstrapping them from small amounts of in-domain data. As I mentioned, reinforcement learning-based systems have also made a comeback. Then I recapped some of the early end-to-end neural models for dialogue generation, and I used the end-to-end NLG shared task to demonstrate to you some of the challenges in this area. And then I introduced some of the fundamental safety problems these systems are experienced, and I talked about examples from the Amazon Alexa Prize. And I've also presented to you, very briefly presented to you some work on addressing these safety issues. Then finally, I presented some ideas of how to avert the final catastrophe. So alignment is one of the areas I'm personally really excited about. I mentioned learning from human feedback. And, sort of as a next step in my career, I will be joining DeepMind in not that far in the future to work on exactly that issue. So this is sort of my short summary of what I think happened over the last 20 years in this area, the important themes which I try to highlight. I think human evaluation or evaluation in general is very much underexplored and under-researched area, which comes back into focus over the last couple of years. And this is also something which I think through my career was always something I was very excited to work on. So thank you so much for listening, and I hope that despite being an online talk, I hope to have that you have find it enjoyable and entertaining to receive questions. Thank you very much.
We have plenty of time for questions. I'm just going to see if we can let Verena hear your questions directly. We had problems a minute ago. Verena, can you hear me now? That's perfect. We've got a complicated mic mute setup going on here. So any questions from the audience? Well, whilst people are thinking of a question, I'd maybe like to start by asking you if you've thought specifically about problems with spoken dialogue systems. Obviously, a lot of the work you've done is in spoken dialogue systems, but with the increasing advent of end-to-end systems that move directly from speech, I wonder if you've seen any specific safety barriers or risks around that.
This is indeed something I think most of the current work sort of assumes the ASR problem to be solved. However, I think also one of the main differences is that speech is usually disfluent, contains grammatical errors, and which we don't really see in text-based interaction. So one of the areas, for example, I'm interested in is whether these systems are still robust to speech phenomena. And in particular, to what extent, for example, speech can even introduce what we would call adversarial examples. So adversarial examples are examples which actually change the system behavior to either different output if you look into discriminative models, or to an output which you think is wrong or unsafe. And I think that's where speech can potentially introduce, unknowingly introduce these type of adversarial permutation, either by some grammatical flaw or some some noise where you know the text-based output then changes. So this is obviously especially important for systems which are in, I would say, safety critical interactions. So, for example, we're looking into systems which are used by blind and partially sighted people and how safe they are to so-called noisy or adversarial examples. So this is one area, and I believe this type of adversarial testing has also been explored, by, for example, a paper called red teaming paper, a red teaming approach, where you basically use another language model to generate all possible permutations. Again, this is text-based, not speech-based, so I think there is still a lot of interesting work to be done in actually simulating spoken interaction and testing these models with spoken interaction. Having said that, these end-to-end models are obviously also very good for SLU, so spoken language understanding, which I believe is now like a really interesting and exciting growing area where people directly learn semantic representation from the speech signal rather than having a transcription in between.
Thank you very much. I think we've got a question here from Roberto. Hope you can hear that.
Hi, Verena. First of all, I want to say hello. I really enjoy your talk, an amazing talk. It also made me think about the past 20 years of my career, my life. And you talk a lot about the end-to-end systems, open-ended system like chat, mostly chatbots, right? That we talk, and that is, and one thing that I'm very, and, because we talked a lot about that, I'm very interested into is how can we make the system actually do something useful? Today we have what we call AI assistants or virtual assistants that are very sophisticated systems that allow people to practically use natural language to produce commands, to command objects like timers, alarms, media, and so on. But that's not also, I wouldn't say they are really conversational. When we talk to someone, an expert, we have a conversation and we have a negotiation. So what can you tell? What is in your mind? What do you think? How do you think this end-to-end approach will evolve towards what I guess Amazon calls task bots or things like that? Yeah.
Roberto, this is a really interesting question, which actually brings me back to my very first system, Hermione, the talking washing machine, where people actually were not interested in using it as a washing machine. They just wanted to hear the jokes, right? So in a way, I think that's where we are at the moment. There are these systems we want to chat to. They're entertaining. Probably after playing around with ChatGPT for a little bit, you get bored and you think like, yeah, what's the point of it, right? Where can I actually use it? And you lose interest and you stop using it. So here I think a really interesting research direction are obviously systems which are grounded in another external knowledge source. So I briefly mentioned knowledge graphs. So that's something, to ground your systems into that actually have content. There are also interesting retrieval-based models which basically retrieve information from the internet. Again, here one of the challenges is how can we make sure that the information they retrieve is actually true and that they faithfully also represent this information. So I've briefly talked about that. Even if the underlying information is faithful, these models tend to hallucinate. So that's another sort of interim challenge, that you have information, but do they actually represent it right? And then there's also multimodally grounded systems, so systems which can talk about, for example, your surroundings. So here we've got, our team is currently taking part of the Amazon Alexa SimBot challenge. So that's where you've got basically robots going through an environment, and you're supposed to direct the robots into the environment by giving it tasks and referring to objects in the environment, which I believe is actually quite a hard challenge, also called embodied AI. And I also briefly mentioned application areas to people with disabilities. So, for example, we are working on a data set with blind or partially sighted people, and that's obviously something which can really help people, and where people actually get a real benefit of using these systems. Safety issues here are obviously even more prominent.
Thank you very much. We've got time for one or two more questions. I think everyone's enjoyed their lunch too much. Yes, we have one at the back there.
Yeah, hi. Thanks a lot. First of all, thanks for your very interesting talk. I was wondering if now with the new end-to-end approaches like what's going on? Okay. Do you believe we are close in completely, let's say, abandoning the notion of intents, for example? At least that a designer will predefine the intents, and somehow this will come up naturally from an end-to-end model without having someone to predefine the intents, and also maybe the slots or the entities and so on. That's my question.
I think there's a lot of interesting research in this area, which I follow. And it's not something I've personally worked on, but my belief is that intent can both be limiting, but obviously also helpful. So once we start, parsing something into intents, we might actually lose some of the nuances of what people actually said. There's also obviously another layer of possible error we can introduce by actually misclassifying something as an intent. But what we gain from it is controllability and explainability. I think it very much depends on your application, what you value more or what is required, right? To what extent you need to be able to highly control, explain what your system is doing, and this is often required in safety critical approaches in industry, versus do you just have a bot people want to chat with, or for example, you're building a bot for a computer game where it doesn't matter if the bot says something slightly wrong or controversial. So I think it very much depends on the application setting. I think that's also one of the reasons why, for example, in industry, people still use the modular architecture, which I presented at the very beginning, which is now, 20 plus years old, but yeah, still use. Did that answer your question?
Hello.
One more question at the back.
Hello. Thank you so much for your talk. For dialogue system, we're looking for consistent conversation, no? What is the definition of inconsistent conversation? Do we have definition of inconsistent conversation? Yeah.
That's a very interesting question. That's actually, I'm supposed to examine a whole thesis on this topic, which exactly explores that. So I think consistency, people usually have two views on what consistency means. So one is consistency within a conversation, so with respect to the previous dialogue context. So do I, follow up in a coherent manner? So consistency and coherency are linked to that respect. And then there is also consistency with respect to facts, right? And this is where the groundedness comes in again, which I already mentioned. For example, if you ground your system in a set of facts which define a persona. So for example, you tell the system, you're 18, you're female, and you're very outgoing, right? Then you want to get the repeated response, which is consistent with these facts. So if you ask the system, how old are you? It needs to give you the correct response. And then if you ask, a couple of turns later, it still needs to give the same response. So in that respect, there are these two aspects. So one is fact-based consistency. And here again, you've got the problem of hallucinations, where even if you have specified your facts, systems might not be faithful towards these facts and make up things by themselves. And then you've got the consistency, or I would say coherence within a dialogue. And that's with respect to, your coherence with the history, and people use, different encoding mechanisms where they also consider the dialogue history and, attention-based models and things like that. But this is indeed one of the challenges which people struggle with. Some people might disagree with this notion of consistency. I mainly base my my definition, as I said, on the thesis I'm just reviewing, and I've not made it to the very end, so maybe I'm missing the clue in the end.
There's one here at the front, Dong.
Thank you for the great talk. I mainly have a question. What's your opinion on what should be the right way to evaluate dialogue systems?
I love that question. Thanks for asking. So as I mentioned, evaluation, I think, is something which is really close to my heart, and which has sometimes been not regarded as one of the central questions of data-driven dialogue systems. And I think that's might be changing now with learning from human feedback. But I think historically there was much more focus on evaluation. So, for example, when we were trying to publish a reinforcement learning based systems, you typically would first present the results in simulation, and then you needed to show that actually it also works with humans. So you always had to have a human evaluation. So I think that's still to some extent the case, that you have like automatic metrics, and then people very quickly aim to gather data on Amazon Mechanical Turk, which I also think is problematic, because you actually can't guarantee quality on Amazon Mechanical Turk, nor you don't know what users actually evaluating. So there are a lot of challenges, I think, to get really good data from humans and dialogue evaluation, especially if you evaluate a whole system. There are often aspects which you can't control for. So for example, when we entered the Amazon Alexa challenge, we suddenly saw our, so in the end, Amazon asks the users to give you a rating. I think it was from 1 to 5 or 1 to 6 or something like that. And we suddenly saw this rating plummet. We had no idea what was going on. And then we looked into all the low-rated dialogue systems, and we found that every time we mentioned Donald Trump, who was president at the time, the user gave a very low score, because they usually disagreed on what we said about Donald Trump, and that no matter what we said, it was somehow wrong. So it was just the topic our system decided to bring up, which actually caused this dramatic fall in human scores. So that's something which is really hard to control for if you've got an open domain system. And something which, it's currently not reflected in automatic metrics. So I think there's a lot of interesting work in actually, especially in NLG, natural language generation, to come up with metrics that better reflect human scores. There's lots of interesting work, for example, at CMU. And there's also interesting work by Anja Beltz on replicability of human evaluation. So, so I think this is an area where we can also learn a lot from HCI. So that's a community which I think, especially the dialogue community, historically had a very close interaction, and now I think there's beginning to have a revival of that sort of overlap between dialogue and HCI again.
I think we've more or less run out of time, so let's thank Verena again for an absolutely fascinating talk.
So much for the invitation. I really enjoyed it. Thank you.
And especially thank you to joining us during a school strike remotely. We really appreciate that. So for everyone here, we've got half an hour coffee break now, and then the final poster session of today will start in half an hour. And also demo sessions, which are going to be